All right, class, this lecture is going to be about wrapper classes. Now, wrapper classes take a primitive type like an integer or a double and even bytes and wraps them in a class, wraps them in an object that we can use a little bit later. The question becomes, why would we do this? And the reason we're going to do this is because there are more complicated data structures later on that we're going to work with, especially array lists that require that you use objects instead of primitive types. And so these primitive types can't be used in those, so we need to use wrapper classes in order to store our primitive data. So let's talk about these wrapper classes. Wrapper classes. So as the name implies, it's going to wrap around our primitive data types. And there are two wrapper classes that we need to discuss. That's the integer, spelled with a capital I and the full word spelled out, and the double wrapper classes. So this is similar to the primitive data type, double is, but it's with a capital D now. So these are our wrapper classes. And they take the same information that we would use for an integer or a double, but now we've wrapped it in a class so these become references when we use them. We're going to declare them and instantiate them just as we would any other class. So let's say we want to create a new integer. We would simply say integer, let's say integer I equals new integer, and then we can give it some value, let's say 36. Okay, so now we've created an integer I. I stores a reference to an integer object that has our value of 36. And just like any other object, this comes with some methods that we can use. So some methods that both double and integer have are this. So we have the dot equals method. And then we put another integer inside of here. Or we can even put a primitive integer. We can put either or. So we could put an int here. And we can see int sum int. Make sure that's a capital I. And so we have an integer sum int in here, and it will see if those two are equal, and it will return a Boolean, a true or false. False. Spell false right. So we'll return a true or false for us if what is on the right side of the equals method is same as what's on the left side. So what's inside here, rather I should say, what is inside the parentheses is equal to what's on the left side of the dot. We also have the compare to. Just like we had with strings. So we can put either an int or an integer in here. So we could say integer sum int inside of here. And this, oh sorry, I just realized my closed parentheses on both of these were different colors. The integer sum int here will compare and give us will return either a negative, a positive, or a 0 value depending on the output. So just like in our compare to for strings, we will do this. So let's say, I'm going to say I here just for expediency in explaining this. So if I if I is less than some int, it returns a -1. If I is greater than some int, returns 1. And if I equals some int, it's going to return 0. We'll talk about why I use double equals here in the next unit. So I.compare to integer some int. Okay. Some other methods that we have. We also have a, let me check my notes here. Those are the two actually that I really care about. There's a toString, but we don't need to call toString. So we don't care about that. Let's talk about some static constants. So static constants, and there's really one that we care about, is the integer max value. I'll explain what static means later, but let's say we want to find out what the maximum value of an integer is. And this is for both our reference type and our primitive type. What is the maximum value of an integer? So we type it like this, and it's exactly like this. We type integer dot max underscore value. We actually talked about this in an earlier lecture. Integer.maximum value will return for us, lo and behold, the max value of an integer. And we know that if we store this in an integer, we can't add anything more to this. So if stored in an int, any addition will cause an overflow error. We've already discussed this, but I just want to make sure that we have this solidified, that integer.maxValue is the absolute maximum value of an integer, the primitive or this object. That is the maximum value that it can store. Same thing with an integer min. Dot min value, all capitals with an underscore. So if I take integer.maxValue and save that into I, so if I, let's move these notes over a little bit. If I did this, if I say I now equals integer.maxValue, and then I say I plus plus, the next thing that I will actually be equal to is I will then have integer.min value. It will overflow to the other side of min and give us our integer.min value. All right, I'm going to go ahead and end this part of 2.7 here. I will pick it up in the next video.